On today's topic, we'll be talking about carboxylic acids and their UPOC nomenclature. Carboxylic acids are characterized by having an R chain or any carbon chain attached to a COOH functional group, also called carboxyl. Carboxyl is the resulting group of a carbonyl group with a hydroxy group, which if we write again in its expanded form, we have C double bond O, which is the ketone group, the aldehyde group, attached to an OH group. Now remember, this can also be written the other way around. So we have HO, C double bond O, and the R chain to the other side. Now, how does this translate to skeletal formulas? We write our carbon in the center, oxygen at one of the cusps, OH, and here we have one carbon double bonding to an oxygen atom and to the hydroxy group. In this case, we have one carbon atom, so the name of this acid, we would take the parent alkane name, we would drop the E, and we would add the suffix oic, and I'm going to take another color to write this, alkanoic acid. Now remember, this is IUPAC or UPOC names. So in this case, since I have one, it would be methane. Methane. I drop the E and I add the ending. Turns into methanoic acid. Now remember, carboxylic acid groups occur at the ends of carbon chains. So in this case, we do not need numbers for these chemicals because the functional group will always take position number 1, especially because carboxylic acids are the most important functional group family when we're identifying simple functional groups. So let's draw another little example. O double bond, OH, this is my carboxylic acid group, my carboxyl. And then I add another carbon. This would be 2 carbons, right? So we take the parent name, which is ethane. We cut out the E, substitute for the ending, and we would get ethanoic acid. And so forth. 3 carbons, propanoic acid, 4 carbons, butanoic acid. Let's do a few more sketches here. And I'm going to start with the simplest acid, which is one carbon atom with its hydroxy group and its carbonyl, so the carboxylic acid group. Then we can draw another one here with 2 carbons. Then we can draw a subsequent one with 3 carbon atoms. Then we're going to draw another one. Make sure that the hexagon, that the shapes that you're drawing do not overlap in the other hexagons. And here we have 4 distinct carboxylic acids, which could also be written in another rotational form. It doesn't matter, but just as long as you have this double bond O next to an OH, we are talking indeed about a carboxylic acid, right? So I'm drawing the same one here, but it's pointing over to the other side. And then we have another one. Another way to draw it is just draw your chain. And then at the end of one of those chains, attach that O with the OH. And it's all going to be good. Here I'm going to do 1, 2, 3, 4. And, well, that one's not going to work on this side because I would be overlapping. But here I have O, OH. And it's the same idea. Methanoic acid, ethanoic acid, propanoic acid, butanoic acid, right? I'm going to draw a 5th one, which is with 5. 1, 2, 3, 4, 5. And this is, again, pentane. But since we have the carboxyl on this side, we're going to cross out that E, and this is going to become pentanoic acid. And again, here we have those names for UPOC nomenclature. Now, it's really interesting because we also have other names. When we speak about the common names of these acids come from the names come from the original chemical compounds in which they were discovered. And right now, we're just going to look at the first 5 prefixes. So depending on the amount of carbon, number of carbon, 1, 2, 3, 4, or 5, we're going to get different prefixes. For UPAC, we get meth or methan. For 2, we get ethan. For 3, we get propan. For 4, we get butan. So again, it's the same thing without the E at the end, okay, from the alkane. And then we get pentane, but we're going to leave it up to the end. So again, methanoic, ethanoic, propanoic, butanoic, pentanoic. But for common names, we get new little prefixes that we have to memorize. And for number 1, it's going to be form. And for number 2, it's going to be acet. For number 3, it's going to be propion. For number 4, it's going to be butyr, B-U-T-Y-R. And for number 5, it's going to be valer. But in this case, instead of adding the whole oic acid ending, we're just going to add ic acid. And I'm going to write that again. Common names end in ic acid. And in this case, how do we do this? This one that's called methanoic acid, we take its prefix and it's going to become formic acid. This one that has 2, we're going to name it with acetic acid, which by the way is vinegar. The vinegar we eat and drink and cook with in its diluted form. Then for number 3, we're going to get propionic acid. And for number 4, we're going to get butyric acid. And for number 5, we're going to get valeric acid. Once again, all of these are using the ic acid ending, not oic, just ic acid, ic acid, ic acid, ic acid with its original prefix. Now, in the next exercise, let's say we start getting substitutions. So I'm going to draw a few of these 5 carbon acids. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We turn them into acids. Right now, they seem like they're going to be aldehydes. But once we add that OH at the end, the OH makes them an acid. And let's just add stuff here. I'm going to add 1 branch here. I'm going to add another branch here. I'm going to add a halogen right there and another one right here. And then here I'm going to add more halogens, for example. So, as with other UPAC molecules, we identify the longest chain, which in this case, let's count each of them, starting with the functional group, who's the star of the show, carbon number 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. 1, 2, 3, 4. So yes, we took the right chain. 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Remember, the halogens do not count for the naming of the chain, right? So in all these cases, we're going to have what? Pentanoic acid. So the main chain is going to be pentanoic oic acid. And this, what we're doing right now in black marker, I'm going to write it up here. It's UPAC. Black marker. So again, this is pentanoic acid. I'm going to write these down really quickly. Noic acid and pentanoic acid. Right? So in this case, what we're going to get is, and let me add something else here, just so that it serves for the example. So we have our pentanoic acid, but then what do we have attached? We look at this one, yellow, and it's a methyl group, and the methyl group is attached at 1, 2, 3, 3-methyl pentanoic acid. Now remember again, if you're a little bit distracted, you might make a mistake, but always remember to number your chains. That makes it so much easier. 5, 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. So here we have 3-methyl, and over here let's highlight what's left over. 1, 2, 1. So let's see, here we're going to use alphabetical order. We have an ethyl group and we have a methyl group, so it's going to be ethyl, methyl, and ethyl is at number 2, dash ethyl, and methyl is at number 4, 4 dash methyl. Here we have 2 chlorine atoms at carbon number 2. So we need 2 locants for that, and we're going to do 2, 2, di to indicate that there's a repeating group, dichloro-pentanoic acid. And last but not least, 1, 2, 3, 4, 5, we have fluoro and iodo at the same position, which is number 5, right? Good. So this is for UPOC names. Now, for the last part of this video, when we have common names are a little bit different. Remember, we use the prefixes that we saw in the past exercise, which are these, Formic Acid, propion. But also, when we draw the molecule, and I'm going to draw this molecule again, OH, 1, 2, 3, 4, 5. Carbon number 1 does not count for this type of naming. We're going to start with number 2, which is alpha. Carbon number 3 is beta. Carbon number 4 is gamma. And carbon number 5 is going to be delta. So alpha, beta, gamma, delta, right? And as we saw with the other example, we substitute the names. So in this case, remember here we have our prefixes for this, for the common naming. Now we have our letters here in the middle. So how are we going to name these using common names, which I'm going to write in red? Common names. Pentanoic acid is number 5. It's Valer. So all the pentanoic acids are going to be turned into valeric acid. If it was 4 carbons, you would change it to butyric. But on the other hand, now it's just about switching the numbers, the locants for Greek letters using this chart. So in this case, we have 3-methyl, and we see that 1, 2, 3, 4, 5. 3 is beta, so this would be beta-methyl valeric acid. This one would be ethyl is at number 2. 2 is alpha. Alpha ethyl. 4 is gamma. Gamma methyl valeric acid. In this case, number 2 and number 2 are substituted by alpha, comma, alpha dichloro. And again, 5 valeric acid. And finally, number 5 is substituted by delta. So we have delta fluoro, delta iodo, and pentanoic acid becomes valeric acid. So I hope that this was clear and that you understood the videos. You can always rewind. And I hope you enjoyed this brief tutorial on how to name carboxylic acids.